In this video, we will see code implementation.
Now quickly see the code implementation of quick sort. Okay, so again, I have one sort array is inside this function. I will call everything. I have one function where I have the nums value. Okay, and now here I will return basically my quick sort function where I will pass this nums and I will say do basically run from 0 to nums.length length minus 1, and this is this, and I will simply return the nums. Okay, now I need to define quicksort. What is quicksort? So let's define function quicksort. Okay, where I will have nums and I will have low and high pointer. Okay, once I have defined this, let's put it like this. Yeah, once I have defined this, now if low is greater than equals to high, what I will do, I will simply return. Okay, if this condition is true, otherwise I will find the index partition index. So partition, okay, where partition will be, I will pass the nums, low pointer and high pointer. This will give them partition index. Now I will call quicksort my function with the two values nums with low to index minus 1, and 1 will be index plus 1 to high, index plus 1 to high. These will be the two values. Okay, now, yes, the call is done, quicksort is done, right? This is the quicksort. But here we have used partition. So let's define partition as well. So I will write a function partition, okay, where I will pass the array, this low and high pointer. Okay, this is done. Now I will create let left equals to low, let right pointer equals to high, and then let pivot equals to low. Okay, and while left is less than right, what I will do, I will simply, while left is less than right, what I will do, I will simply say while, okay, two conditions will be there. While left is less than high, okay, and AR of left is less than equals to AR of pivot, can't see AR of pivot, then what I will do, I will do left plus plus. With the same while loop, right, I will do right plus plus, but there will be few tweaks here and there. So right plus plus, but here the condition will be changed. Here instead of left, I will put right, and instead of high, it will put low, and it should be right, should be greater than low. Okay, that's the thing. Here we should put right, and here it should be greater than, because less than and equal to condition, I am taking the upward. Okay, I have covered two while loop. Now, whenever you will come from this while loop, and if left is less than right, what you will do? You will do swap, right? So I will do swap AR of left and right. Okay, right. RIGHT, right. Okay, this is done. So this is also done here. Now what you will do after while loop? What you will do? You will swap it again. Swap AR of right and pivot. So right and pivot, and you will return the right, that is your partition index. Return right, and that's it, it's done. Now the only thing is, because we have created a swap, so let's quickly define function swap that will take one AR left and right. Okay, now we will take one variable temp equals to AR of, suppose, left. AR of left will become AR of right. RIGHT, and AR of right will become AR of left. Done. Simple. Okay. So this whole thing is done. Now only few tweaks here and there will be basically see. Now this will work, but I have mentioned there are some edge cases. What are the edge cases? If the array is already sorted. So if the array is already sorted, okay, and you are taking low, so the always the partition will be from low and the time complexity will become big of n square, because in every time you are taking low, every time you are taking low. So in that case, what you can do, you can take the partition, basically you can start from the middle index. Okay, so instead of passing low here, you can start with the middle. Okay, let me show you. So basically you can do it here as well, right? In low, instead of low, what you can do, you can take the middle, like basically mid is equals to method dot lower. Okay, low plus high by 2. Okay, but you need to change few here and there conditions. So you can simply copy this mid and instead of here, you can put it here. Okay, mid dot blue low plus high by 2. Okay, and you can do swap AR of mid and your left, sorry, low. So what you will do, you will swap them. Okay, AR are its nums, so nums of mid and low. So once you swap it, right, your mid will become low and low will become mid, right? And then when you pass it, right, the numbers will be changed. Okay, so this will help you when there are all if numbers are same. Suppose if all the elements are same, then again the time complexity will become big of n square. But if the array is already sorted, then this case will help. Okay, and now if you pass basically this in lead code, you will again get TLE, time limit exceeded, because in JavaScript, if we are applying this, it takes time, right? It takes time. So this will take time. Again, instead math should be capital. Okay, again here, what one more thing you can do, instead of this mid, you can take random. That is also possible. So random equals to, basically you can use method dot random, and you simply again you can do low, basically method dot random will be method dot floor. Okay, and then low plus high by 2. Basically you need to take a random element and then again you can swap them with your low. That is also possible. Okay, but again it will give TLE, because in the lead code, if we are running with the JavaScript for these cases, these extreme cases, it will give TLE. But if you add the same code in the GFG or Geeks of Geeks or any other platform, this will get accepted. Okay, in the, if you want to do accept in the lead code, that is also possible, but you need to tweak a little bit and you need to change your partition, basically how you are finding partitions. So instead of creating while loop here left to right, okay, we need to change it, because if there are same number of elements, but I am not changing it because, see, the basic algorithm, if you are in front of interviewer, even the interviewer is asking, he or she will is also expecting you to answer like this, right? Everyone is expecting to answer like this. Okay, and suppose if you come up with some different algorithm, that will basically, for a particular answer, it will confuse you more. Okay, so basically this is the correct approach, and this is the well this is the most asked question. Okay, this is how it asked, they will ask questions on this your code. Okay, so this is the correct code. I want you to understand this and submit to the other platform GFGs, and there, if you can simply tweak this partition, okay, you can submit in the lead code as well. So that's all for quick sort. Okay, I hope you got all the sorting algorithms very correctly. Okay, we have also done the dry runs of it. Okay, so you are very clear with these sorting algorithms. So okay, from now onwards, I will take more problems on again the same series after sorting algorithms, and we will see more types of these problems on graphs, on DPs, on vector. Okay, so that's all for this video. See you in the next video.